Let's look into something called as chain rule. We are trying to figure out the derivative of y with respect to x over here, wherein y is equal to 4x plus 7 the whole square. Traditionally, this is what we generally do. So we have y is equal to 4x plus 7 the whole square. We expand it. So this is 16x square plus this would be 856x plus 49. So I've used a square plus 2ab plus b square. 2 into 4, 8 and 8 sevens are 56. Now we have to differentiate this. For that we will make use of, if y is equal to x to the power of n, then y prime is n into x to the power of n minus 1. So this would be 32 x plus 56 into 1 plus 0, because the derivative of a constant is 0. Now we can approach the same problem with something called as chain rule. So the basic aim over here is to find dy by dx, right? Remember, dy by dx is nothing but delta y, which is nothing but y2 minus y1, so on and so forth. Now I will handle this like a ratio. This is a ratio actually. So like any ratio, I can do this. I'm splitting the numerator and denominator in this way. And like any ratio, we can multiply and divide with anything that we want. Say in this case, I will multiply and divide with dt by dt. This is from the idea of multiplicative inverse. On rearranging, we have dy by dt into dt by dx. I'm just rearranging. Okay. Now, what is the point of this? How to make use of this? How to make use of this idea? We'll go back to y, which is 4x plus 7 the whole square. I think I'm right about that. Yeah. What I'll do is I'm going to call t as 4x plus 7, not the whole square, just that. Now with this in mind, my y, I'll write it over here, my y will become, therefore my y will become what? T square. If I differentiate y with respect to t, what will happen? It will be 2 into t. Again, this is just variables, treat them like one. Instead of x, we have t. That's it. Does it make sense? Now coming back to t, which is 4x plus 7, I'm going to differentiate with respect to x. So we'll end up with 4 into 1, that is 4. Finally, I'll go back to my original expression y prime over here. So y prime is equal to dy by dt, which is over here 2 into t, into dt by dx, which is over here, which is 4. So basically 8 into t. But t is what? But t is 4x plus 7, and further simplification will give us 32x plus 56, which is same as this. So this helped us finding the same answer but in a different way, by the idea of substitution basically. So this is the entire funda. That is, given dy by dx, we can always find it by dy by dt and dt by dx and so on and so forth. So the formal definition is over here. So the basic idea is it helps us in finding the derivative of a composite of function. So basically, if I have y, which is say composite of, I have it over here actually, v composite of u of x. So it's made up of two different set of expressions, combination of that. If I want to find the result of that, I can use our chain rule. So we're going to see more complicated questions on this. This was a very simple one, to be honest. So the theorem statement is, if or let f be a real valued function which is a composition of two functions u and v. So basically f is v composition u. Suppose t, which is u of x, and if both dt by dx and dv by dt exist, we have y prime, if not dy by dx, which can be written as dv by dt into dt by dv, sorry, dt by dx. This is basically what we did just now. Okay, let me give one more example to concrete the idea. I have y is equal to x square plus sin x the whole cube. Yes, it looks similar, and yes, we will make a similar, will make up the similar idea itself. But again, just another example. We're going to see more complicated questions in the future. So I'm masking all of that. I'm ignoring all of that. I'm taking all of that as t. Okay, so y is equal to t cube. Now I'm going to differentiate y with respect to t. So we'll get 3t square. Okay, quite simple. Next, I have t, remember. Now I'm going to take t and differentiate with respect to x. So I get 2x, right? Because differentiation of x to the power of n is n into x to the power of n minus 1, and sin x is cos x. And finally, we need dy by dx, which can be written as dy by dt into dt by dx. Okay, basically the above two expressions. Instead of t prime, I should have written it as dt by dx. Anyways, now all I have to do is substitute it, and we have the final answer, right? So basically we have to skip all the intermediate steps and we can write the final answer. You will understand in time how to get directly from the start to the end without doing such a substitution. So it's an easy thing to guess that we can have any number of substitution. I can end up with y, which is say v of u of w of x. So it's basically 3 composition, and this would be dv by d. I can substitute actually. We can discuss a bit more. Let me do that for you guys. So y is, so it's composition of so many things. So we will call omega x or w of x as t, and u of omega of x as a overall thing as say r. So basically, with all of this in mind, I can find dy by dx as dv by dr, then differentiate dr by dt, that is this expression, and then finally differentiate dt by dx. So we can see technically this and this will get cancelled, this and this will get cancelled, and we'll get back the original dv by dx. That's what we want, right? So you can have any number of substitution, and of course we need to understand which will come first, which operation will come first, and composition has to be understood properly. So we have done composition of functions, so I hope you guys have a good grip on it. We're going to do a lot of problems, don't worry. So for now, copy everything, don't miss anything. This is not multiplicative inverse, this is multiplicative identity.